All right, let's talk about convergent and divergent sequences. To know if a sequence converges or diverges, it's super similar to a limit. If the sequence has a limit, meaning it approaches one unique number as n gets really, really large, well, then it's called convergent, right? Divergent means, okay, this thing is going to infinity, negative infinity, or maybe it's oscillating or alternating numbers, right? And it can never pick a single value to approach. So let's look at these. I like to think about them as functions and just can logic my way through it. Okay, what's going to happen if n gets super big? If you're a plug and chug type of person and you want to just keep plugging in values to see what number it approaches, or maybe put these numbers in a table, you can totally do that too. But I'm going to go through how to logic this out. So first things first here, let's look at this one on the left. And we look at n and we think about, okay, what happens if I plug in a super big number? Like I'm talking a billion. Well, I'd have 4 billion minus 2, which is still super close to a billion. And then in the denominator, I would have 3 billion plus 6. That's still super close to 3 billion. So as n gets really, really big, right, there's still an infinite amount of numbers that are bigger than a billion. Well, this minus 2 and this plus 6 become obsolete. They don't really matter. Well, now we've got a different fraction. Now I'm just interested in 4n divided by 3n. Well, I've got an n and the top and the bottom, so those are going to become 1. So this one is just going to approach 4/3. All right, a common rule to follow is if the degree on the top and the bottom of our rational function is the same, that means they're going to have the same amount of growth. So we're going to end up approaching whatever the coefficients are divided, right? So the coefficient of this one, we got 4 and then 3, so that means we're going to be approaching 4/3. Sometimes, though, we're going to get some sequences that look a little different, right? Here we see we've got an exponential and we've got 2 n's to the power of 1. So let's see what would happen as n gets really big. Well, when n gets super, super large, just like the last one, these constants just don't really matter, right? A trillion minus 2, okay, not really much different. Now that I have this, well, that becomes 0.4 to the n times n over 6n. Well, I got an n in the numerator and in the denominator. So that becomes 0.4 to the n divided by 6. And now you really need to think about what's going to happen. If you're just looking at this and you see that, oh, n's going to get super huge and it's in the numerator, this is going to shoot off to infinity. You have to be careful because it's a decimal to a power, right? When I put 0.4 to the 10th power, 0.4 to the 100th power, that's going to get really, really small. Whenever we put a decimal to an exponent, it gets smaller and smaller and smaller. So as n gets bigger and bigger and bigger, this part right here is going to approach 0. 0 divided by anything, as we know, is 0. So we would say that this sequence, it converges, and we would say it converges to 0. This one over here converges to 4/3. Right? But what if, looking at this same one on the right, what if I traded out that 0.4 for, let's say, a 5? Well, same thing would occur, right? This 2 doesn't matter. These n's cancel out. And then I would have 5 to the nth power. Well, 5 to the any power, well, if that power gets bigger, that's going to get huge in the numerator. So this is going to get to infinity, right? This is just going to shoot off and keep increasing and increasing. So we would say that this one diverges. Yeah, I spelled that right. um, because it doesn't approach a single value.